Good morning, good afternoon, good evening. Wherever you are watching this video, let me welcome you all to our channel Future Endeavors. In the last class, we have discussed about the techniques of measuring length. Especially, we have discussed the technique for measuring very small lengths like the diameter of a wire, diameter of a ball, like this. Today, we are going to talk about measurement of time. And you know all that for measuring time, or actually for keeping a record of the track of the time, what we generally use a watch. Okay, now you must have seen in the olden days that the watch that our forefathers used to see for keeping a track of time were all pendulum watches, pendulum clocks. Okay, so basically a pendulum was initially the main component for keeping a track of the time. Okay, so today while discussing about the measurement of time, we will be first discussing about the simple pendulum. So what is a pendulum first? Okay, so before starting the video, let me please tell you that do subscribe the channel, and please also, if possible, please share this video as much as possible so that it can reach to more people, so that more people can be benefited from these videos, this kind of videos. Okay, so what is a simple pendulum? First we are going to discuss a simple pendulum. So what is a simple pendulum? So simple pendulum, you must have seen that it is nothing but a heavy mass which is attached to a rigid rod. Okay, it looks something like this. There is a rod of certain length, not very thick, it's a thin rod. Okay, and at the end of the rod is connected a spherical mass. Okay, rather you can say it to be a plate like structure, not very thick, rather plate like structure. So this kind of structure is called a simple pendulum. Okay, so actually, and this is attached to a rigid support. Okay, attached to a rigid support here, and it can actually swing, okay, to and fro. It can come to this position like this. Okay, like this position it can come. You can again move to this position like this. Okay, so you can swing about the fixed point. So like this, then it goes like this, then again it comes back like this. Okay, so this is how a simple pendulum moves. Now, before telling about the simple pendulum, we will be discussing certain terms which are related to simple pendulum. What are those terms? Let us see the terms related to simple pendulum. So the terms, what are the terms? Terms related. Okay, so first of all, what we are going to discuss or say about is oscillation. So what is oscillation? Okay, so first point is oscillation. Please do take out your pen and diary, and if possible note down the points, or at least write in your copy so that it is easier for you to understand the concepts. Okay, fine. So oscillations. Now what are these oscillations? Now oscillation is when actually the pendulum is moving. Okay, this is called to and fro motion. Okay, so if you consider this pen to be a pendulum with a say bob attached, I cannot show the bob here actually, but if I just see this pen can just swing like this, isn't it? To and fro, tick tock. Okay, so like this it will just move to and fro. So this motion of the pendulum, this swing of this pendulum, to and fro motion of this pendulum is regarded as oscillations. So what are the oscillations? Oscillations is nothing but the one complete such to and fro motion of the bob of pendulum is regarded as the oscillation. Okay, so when you are saying that the bob was initially, the pendulum was initially like this, it moves to the left, right, for it is right, then it again moves to the left, and then it again comes back to its initial position, the position from which started. This one complete cycle is called the oscillation. One complete to and fro motion, such one complete to and fro motion is called the oscillation. Okay, so I think you have understood what is oscillation. So this is called the oscillation. Now second term is the time period of oscillation. So what is the time period? What is time period? Okay, now see, when I am saying that this pendulum completes on oscillation, it must have took certain time, it must have taken certain time. Okay, so the time that the pendulum, bob of the pendulum takes in order to complete one oscillation can be regarded as the time period of the pendulum, okay, or time period of the oscillation. Okay, so time period is actually a time, isn't it? So since the SI unit of time is what? Second. So definitely the SI unit of time period will also be second. Okay, so I think the concept of time period is clear. Next, the third term that comes is frequency. So the third term that comes is frequency. So what is frequency? Now see, as I have said, say when the bob moves like this to and fro and completes 1 to and fro oscillation, say it takes 3 seconds. Just for example, say it takes 3 seconds. So if I say that the bob completes one oscillation in 3 seconds, you might ask a question. So what will be the oscillation, number of oscillation in 1 second? Yes, definitely you can find out using just simple unitary method. For 3 seconds, okay, is required for one oscillation. Hence 1 second, in 1 second we can see, so it will be 1 by 3 oscillations, isn't it? So this is nothing but the frequency. So frequency is nothing but the number of oscillations per second. Okay, number of oscillations per second, or you may rather take it as per unit time. You can use other units also if it is SI, if the SI unit is not mentioned specifically. So you can use other units also. They may be minute, okay, hour, anything, but the time must be unit time. So that number of oscillations completed in unit time is regarded as the frequency. Okay, number of oscillations completed in unit time. So here we are specifically saying that number of oscillations completed in 1 second is regarded as the frequency. Now, how frequency and time period are related? Time period is related by the letter T, frequency is related by the letter F. Okay. Now, just as I said, if a oscillation is completed in 3 seconds, so time period is 3. Now, what I am doing while finding out the frequency, I am saying that 3 seconds are required for one oscillation. Then in 1 second, the number of oscillations will be 1 by 3. So what I have done, I am just taking the reciprocal of the time period. So basically, time period and frequency are related as T equals to 1 by F, or rather this can be also written as F equals to 1 by T. Whichever is required, we will use to solve our problems. Okay. So this is a relation. Fine. Now, the fourth term that comes is the effective length. So what is the effective length? What is the effective length? Have you any idea? Okay. So effective length. Now see, when the bob is suspended, you know that every body has a center of gravity. Center of gravity, we have read this term in class 8. Center of gravity basically denotes is that point within a body. Very easily, if I say, so in simple terms, if I say, it can be said that center of gravity of a body is the point where the body can be balanced. Okay, it can be, in simple terms, it can be denoted like this. Okay. Now, the effective length is the basically length from the point of suspension to this center of gravity of the bob. This length is called the effective length. So fourth term is the effective length. So effective length is nothing but the length or the distance between the point of suspension and the center of gravity of the bob is regarded as the effective length. Okay, fine. Now see, so the pendulum actually is, when it completes one oscillation, it is called actually 1 second. Okay, generally the pendulum clocks that we have in our home nowadays, we generally do not use the pendulum clocks, but in some houses it may be present. Some of you may have also seen pendulum clocks. Okay, so when the pendulum generally when the pendulum completes one oscillation, its subbing position moves to right, then to the left, comes up to the mean position. The second hand, or there is no second hand in the pendulum clocks. Basically, the one complete oscillation of the bob is taken as 1 second. Okay, so in this way we can actually count the seconds. Now when 60 such oscillations are completed, 1 minute is completed and the minute hand of the clock moves by 1 minute. Okay, one small division on the clock. So in this we can measure the time or keep a track record of the time using a pendulum or pendulum clock. Okay, fine. Now if with the help of the certain experiment, okay, we can actually determine the value of acceleration due to gravity at a certain place. Okay, we can measure the acceleration due to gravity at a certain place. Okay, so what happens is that say if we take a simple pendulum and actually vary its length. Okay, if we take a simple pendulum and vary its length, okay, then we will be getting some relation between the time period and the length. Okay, time period and length. And generally what happens in case of a simple pendulum, if we plot the square of the time periods, okay, it is generally seen that the time period varies with the length. So if I just plot the square of the time period t square with the length of effective length of the pendulum, generally what happens, a straight line is obtained. Okay, straight line is obtained, and it's something, so straight line is obtained, not the plotting of t with l, but rather t square with l, and it's simply a graph like this. Okay, straight line. Fine. So what does actually from what is the utility of this graph? Actually, it is seen that the time period of the pendulum is directly proportional to the square root of the length. If we plot the data or just see the data, it is seen that the time period of a simple pendulum is directly proportional to the square root of the length, effective length. Okay, so as you increase the effective length, the time period does increase, but not actually not very much directly proportional. It is proportional to the square root of the length. Okay, fine. Now if I just consider the plot between t square and l, we will get a straight line like this, and actually you know that we can determine the slope of this kind of graph. I think you know the slope formula for determining slope. Slope is given by change in y-axis data of y by change in data of x, isn't it? This is the slope. So from this graph also we can get the slope of this graph, and actually the slope of this graph, okay, is found to be constant at a certain place. Okay, and slope of this t square versus l graph, okay, so slope of this graph is equal to this constant 4 pi square by g. This is constant, this value is constant for a certain place. Okay, it is, if you just do this in a certain place, and if you just plot the slope, you will be getting this constant 4 pi square by g, where g is the acceleration due to gravity. Okay, so can I determine the value of g from this equation? Yes, definitely. So the value of g will be equal to 4 pi square by slope of this graph, slope of t square versus l graph. Okay, so this is the equation. So this is the formula for the determining formula for the determination of the g, or acceleration due to gravity at a certain place. Okay, acceleration due to gravity. Fine. Okay. Now, so if I, okay, the next topic that we will be discussing is, so what are those factors on which the time period of the simple pendulum depends? What are the factors on which the time period of a simple pendulum depends? Okay, so let us see what are the factors. Okay, so I think you have noted down this relation. Okay, if not, please pause the video, move back a little, and do note it down. Okay, fine. Now see. So what are the next that we are going to discuss is, what are the factors affecting the time period? Factors affecting time period. Factors affecting time period of a simple pendulum. Okay. So what are the factors? First, the first factor that affects the time period of a simple pendulum is its effective length. So first factor is the effective length. Now, as I have already discussed, the effective length, how it is related to the effective length, we have seen that the time period, the square of the time period is directly proportional to the effective length, or rather you can also say that the effective length is directly proportional to square root of the length, effective length. Okay, any one that you can choose. So actually effective length and time period are somewhat directly related. The effective length increases, the time period also increases. What happens when the time period increases? Actually the pendulum moves slow, isn't it? The increase in time period is actually denoting the movement is becoming slow, isn't it? And time period less means the movement is faster. Fine. Okay. Now, what is the can you guess what is the second factor for the time period that affects the time period of a simple pendulum? It is the acceleration due to gravity. Okay. Now, the second factor is the acceleration due to gravity at that place. So, second factor is acceleration due to gravity. Due to gravity. Fine. Now, here again also the time period is inversely proportional to the square root of the acceleration due to gravity. So, t square proportional to 1 by root under of g. 1 by root under of g. So, t proportional to 1 by root under of g. So, this is the acceleration, this is the some relation between the acceleration due to gravity and the time period. Okay, fine. Okay, so if I just combine these two factors, okay, combine these two factors and place the constant value, okay, we get the formula for the time period as t is equal to 2 pi root under of L by g. Okay, so this is the formula for the time period of the simple pendulum, 2 pi root under of L by g. Okay, fine. Now, what are the two factors? Can you just guess what are the two factors on which the time period does not depend? Does not depend. So, first factor is the mass of the material of the bob. Okay, mass of the material of the bob. It does not depend on the mass. Okay, so two factors on each. Just write it inside. Factor that does not affect. That does not affect the time period. So first factor is the mass of the bob. Okay, mass of the bob, and the second factor is the, what is the second factor? Second factor is the amplitude or the amount of swing. Okay, amplitude of the swing. What is amplitude? You know that when a certain thing oscillates, moves to and fro, the maximum displacement of this body from its mean position on either the left, on the right or the left is the amplitude. So the time period does not actually depend on the amplitude or the mass of the bob. So these are the two factors that do not affect. Okay, so I think the concept of time period and concept of simple pendulum is clear. Okay, so why we have been discussing the concept of simple pendulum? Because simple pendulum is the very basic device that we use to measure or keep a track of the time. Okay, so coming to the end of the video, last one topic that I will be discussing is the seconds pendulum. So what is seconds pendulum? So this is just one separate topic, seconds pendulum. Now it's interesting, the time period of a pendulum, of such a pendulum, that is seconds pendulum, is generally 2 seconds, not 1 second. So this kind of pendulum has a time period of 2 seconds. So this kind of pendulum is called the seconds pendulum, 2 seconds. Okay, so this is the seconds pendulum. The pendulum which has a time period of 2 seconds is regarded as seconds pendulum. Okay, fine. So actually it completes one oscillation in 2 seconds. Fine. So this is seconds pendulum. Okay, so with that we come to the end of this class. We have discussed about the various measurement techniques, measurement for length, measurement of time. Okay, so we will be continuing our next topic in the next class. Till then, please do study well, and if you have any inquiry, any thing you are very curious to know, please do mention in the comment box. We will be happy to solve your inquiry, solve your problems. Till then, please do study well. Thank you. Goodbye.